Hey guys, in this video we want to talk about deflection. After you install the bridge and you have a deflection problem, how do you fix that? Here we have Kenny and Jesus with us. Kenny and Jesus both work for Paragon. Kenny is the fabricator in our yard. He does a lot of the metal fabrication. But he just sticks in our yard. He doesn't do any installs. Okay, and next to him is Jesus. And he also does fabrication in our yard, but he also goes out and installs bridges. So he's been to numerous bridge sites and has dealt with this firsthand. Okay, so here we have this is a 19-foot long bridge going in this direction here, 19-foot long. The 9-foot wide decks. We have them side by side here, and here you can tell. Obviously, these are just sitting in the dirt. We didn't want to build full abutments for this video, but this bridge is sitting about maybe an inch lower than this one. Okay, so you're going to find that same problem on bridge decks. Is one is going to be lower or have a different camber than the other one. So how do you fix that? And this is going to apply whether it's these short little 19-footers or a 40-footer or 90-footer. It's all the same thing. Okay, so it's all the same deflection problem. So now we're going to talk to the guys and see what they recommend to fix this. All right, so let's Kenny, we're going to do a little bit of role playing here. Kenny, let's assume come on a little bit forward here so I can get okay, both of you guys. Okay, so let's assume that Kenny, you're hired by the client as your contractor, and Jesus, you are the trainee. So now you have to teach Kenny on how to do this. All right, so we have about an inch of deflection. So Kenny, what I want you to do is pay attention and see if you understand. Now Kenny, well, let me ask you, have you ever installed a bridge before? No. Have you ever fixed the camber on a bridge before? No. So in a site, so this is pretty new to you, right?
Yeah.
Okay. And it this is a lot of metal here, so it does seem a bit intimidating when we're talking about this much metal. All right. So Jesus, why don't you take it away, and how do we do this?
All right. Pretty much, you figure out which one's the lower one and how we're going to pick up the bridge that needs to go up. In this case, you grab this, find your lower one, weld this to your lower deck, put your bottom deck underneath, and then start picking this up.
Okay.
With the pressure, your piston's going to start shooting up, this is going to go down, and this is going to come up. And that's how you're going to start fixing your camber and getting them even together. And you just do that throughout the rail car.
A couple of things I want to interject here is the jack that we have there. It's a hydraulic cylinder. That's an 80,000 pound jack. So you don't want to use a cheap jack. You don't want to go to Harbor Freight and get one of the cheap ones. That is an Interpack 80,000 pound capacity jack. If you use the wrong size jack, or if you use the wrong manufacturer, or if you use just an inferior jack, it's not going to get the job done. Okay, you have to use a high quality, high capacity hydraulic jack. Okay, so Kenny, did you understand that?
Yeah, fairly well.
Now, Jesus, does it matter where you weld that? Actually, Kenny, do you think it matters where you weld that underneath there?
On this?
Yeah.
Yeah, because if you weld the back side, just the back, it'll snap. Whereas he told me to weld it all the way around so that it holds the weight down good.
Okay. Does that make sense to you? Do you have any questions in regards to that?
About how far apart would you have to move this thing? Just wherever the camber's uneven, or is it like every 5 feet you want to check every 5 feet, or
That's a good question. Jesus, what would you say?
I'd say depending on the length that you're going, but keep it around maybe about 10, 15 feet. And also depending what kind of deck you're actually going to put on there. The longer you go, you can stretch out a little bit of it. It'd be easier to play with the lengths.
That's a good point that Jesus brings up, Kenny. Does that make sense? The in general, the longer the bridge, the easier it is to correct camber.
Yeah.
The shorter the deck, like this little 19-footer, the harder it is going to be to correct camber. Does that make sense to you?
Yeah, that makes sense. That just has to deal with tension. If I have a long piece of bar and I'm trying to bend it on the very ends, it'll bend, but if I'm real close together, it won't bend, just tension.
Okay. Couple of things. It is important on certain rail car styles. You don't just want to willy-nilly take that and weld it anywhere on the deck. There are some structural members underneath the bridge. You want to be very careful that you're welding this to good, strong deck material. Otherwise, you will ruin that deck. There's a lot of different variations in the type of rail cars and the type of decking it has. So if you apply that to the wrong place on the deck where it's weak underneath, you will ruin something, right? Because you are applying a tremendous amount of force. Jesus, do you think it would be more or less prudent to start correcting deflection at the center of the bridge or on the edge of the bridge? What do you think?
You have to get a starting point. So if it's real bad in the center, start there and work your way out. But if it's real bad at the beginning, start correcting from that point.
Yeah, not all the time. So does that make sense to you, Kenny?
Yeah, just start where it's pretty rough and work your way across it so that's even.
Yeah, because if you start working, well, I don't want this video to be too terribly long, but when we talk about how bad is bad, you know, we've seen camber all the way up to 1.5 inches, 1 3/4, maybe even closer to 2 inches out of camber on a 90-footer. Well, we can you know, bend that out pretty easily. But what are we typically shooting for? If I had the two cambers within 3/8 of an inch difference between the two, I think I'd be pretty happy. If we got it within 1/4 inch, that's pretty awesome, right? We could get it to balls on 0, but it's a lot of work for not a lot of, you know, 1/4 inch. So what? You know, we can live with 1/4 inch. All right. What else do we want to talk about here? So that's really it, right? It's just a matter of welding that on. Does it matter if we weld that jig to the high side rail car or the low side? Kenny, let me ask you, see if you're paying attention, partner.
The jig's actually got to be on the low side because the bottle jack goes up. So in a sense, it's pushing this deck down and that deck up. If it was vice versa, you'd just be going backwards.
Exactly. Now here, Jesus, why did you choose that particular material? Here we're using some C-channel. Why did you bring out C-channel?
It's strong. It's just a good way to start everything, how you're getting the pieces that you need to get.
Could you use I-beam?
Yeah, if you can make it work. There's a lot of things you could use, but for this is...
It just happened to be what we have laying around, right?
Yeah.
It's nothing special. So you can use, there's a ton of material. Oh, so let's say we were really fighting this thing, and for some reason we're using smaller material, and it's starting to, you know, the horizontal starting to separate from the vertical. Is there anything we can do to try to keep those two pieces locked together better at a perfect square? Could we add any kind of gusset or anything to that to make it stronger?
Yeah, you could weld a gusset from here to this, right here, just to stiffen it up and make it stronger.
Okay. All right. So let's say now whenever we install this bridge, regardless of what bridge it is, we typically want to leave a little bit of a gap in between the two decks. Here you can see we just brought these over with our forklift, but we do want to see a gap all the way down the seam. In this particular case, these are, let me walk to the other side. If you get these two decks bound up, meaning that one's on top of the other, you're trying to fight with it. See how we have this these two angles here. So if these, you know, this one is this one's the low side one. So if this angle here, if we brought this in and this is now underneath here, and we're trying to raise this one, you know, if we're trying to raise this one up but it's stuck underneath here, it's not going to work. So sometimes we need to separate these two bridge decks out. We want to see daylight all the way across. We don't want to see those those tight, even if we have, you know, a ½ inch gap, and very seldom are these cars going to be perfectly straight. One will want to walk a little bit this way, this one may want to walk as well, so it may be slightly touching in the middle but have a gap on the ends, which is perfectly fine. But we want to be able to see daylight all the way down. So if your decks are too tight, Jesus, how would you address that? If these things are just too tight, the crane's gone home, now it's like, oh man, I need to separate these things. What would you do?
You could just grab, for example, these pieces of angle, weld one to one deck, weld the other one to the other, put your bottle jack flat.
You want to grab that, Kenny?
And you could just start pushing against each other to open the cars apart.
Okay. Does that make sense, Kenny?
Yeah. Pretty simple.
And obviously, if you want to do all this deflection correction and nudging around before you start bolting or welding your rail car to the bearing plate, that way we have other videos to talk about bearing plates. When this is sitting on a steel bearing plate, that steel to steel is going to slide really easy. So don't weld anything down here yet until after you do this. Otherwise, you're just going to be fighting with yourself. It's a lot harder. Right? Is that your experience, Jesus?
Yeah.
All right. Anything else we need to talk about, Kenny? What do you think?
It seems pretty simple.
What do you think would be the hardest thing to do?
Probably fixing the camber, just because of having to move the jig and everything. But overall, it should be pretty simple, I figure.
No, are you saying that just because you're on camera, or are you saying that because you really think it's going to be simple?
I think it's pretty simple. The idea is easy enough. Should be functional. It might take more time, but overall, it should be a simple task.
Jesus, whenever we lower, you know, so we're going to bring that deck up and bring that one down. Do you typically want to over correct them in order? You want to over correct them, or what do you typically want to do there?
Depends. If you're gonna put a seam cover over it, you might want to go a little bit above, just so that when you weld it with the actual weight of the other car, it'll correct itself and come back level. But if you're not gonna do that, then you just kind of get it close.
Yeah, because once you let go, now once we get them level, there are some angle iron that goes up underneath the rail car to tie those two together, right? So there is angle. But once you let them go, that they will want to, the lower car will want to settle a little bit more. So yeah, so you have to just mess with it and see what works. You know, it's not. It's just, what do you think? This is it's maybe a little bit tedious work, but not hard work.
Yeah, it's a bit tedious, but not very hard at all.
Yeah, it can take some time depending on what kind of equipment you have and what kind of camber you have. All right, I think that's it. All right, guys, I appreciate it. Thanks. And one thing that Jesus just reminded me of, we may want to show you is, so what if you have these things split up too far, right? So what if, oops, you went too far, you want to bring them back together. Jesus, how would you do that?
Again, you'd use the same angles that you used, and pretty much you could grab a come along or anything, and then just bring this car closer to.
So we would probably, if we did this one, we would probably need to blow some holes in that angle.
Yeah.
Is that right? Or I guess we can always do it like that, right? And put a hook inside here and a hook over here and do that too, right? With the come along.
Yeah.
And then and with the come along, you just, of course, we want a high quality come along. Just suck them back together, right?
Yeah. Once you're in place, then you could get to welding everything that you need to get welded on.
Are these you know, that jig that you made over there and these pieces that we're talking about here? Most of the time we just grab whatever is laying around, right? It's not like we special order anything.
No, yeah. I mean, we just work with what we have around and make it work.
So even when you're at a job site, I know that I've been at job sites, and there's usually some parts on the actual rail car itself that we can take off that are extra and use that as well.
Yeah, I mean, there's a lot of things you could grab onto the actual cars. For example, we got these holes right here. You could get something in there that you could hook on. You could actually use that and bring it together.
Okay. Now taking these things, so we're going to weld them all up. How about taking them off? Is that what's a concern whenever we're taking these things off the deck?
Just grind everything and knock them off, or cut them out with a torch.
What's better, torch or cutting wheel?
The torch, it's a lot faster, and you just go hit it with a grinding wheel and make it look nice.
How about somebody who is not very good with a torch? Imagine we've had some employees that aren't very good with torches, right? What would your concern be having somebody who's not very good with a torch torching on that?
The only concern is cutting too much into the deck.
That's bad, right?
Yeah, that's bad.
So make sure if you are torching it that you're not digging into the to the deck material. If you have any kind of concerns about your torching guy, I would recommend using a cutoff wheel, an angle grinder with a cutoff wheel, because you're less likely to do significant damage with a cutoff wheel than you are with a torch. Torch can get away from you pretty quickly. Okay. Did we show that? Did we show how we have that jig welded up? I don't think we did talk about that, did we? Grab that jig and see if see how we have that. It's just two pieces of steel, right? There's really not much to it, right? And I really don't want to discuss how much weld. I don't want that responsibility of telling you how to weld. If there's any question, more weld is always better than less weld. I really don't want to talk about exactly what size steel you need, because it really depends on the camber. There's too many applications, too many variables. So if you start jacking it, and if it's falling apart, you use more metal, right? It's really that simple. If you need, of course, 80,000 pound of hydraulic cylinder is going to do the job. But if your jig, if it's not, if it's breaking somewhere, see what's breaking at and stiffen it, reinforce it, or use bigger metal, and that should usually do the trick. Okay, the longer the bridge span, the easier it is to fix deflection. And not all deflection is always, the worst deflection isn't always in the middle. Sometimes the worst deflection could be on one end or the other end. And so you work on the worst end, you fix it. Sometimes it is easier to work on the other end and work to the worst part of the deflection. It really depends. There's a lot of variables. So once you start doing this a few times, you'll get used to it, and it becomes a lot easier. All right. Hopefully that's it. Let's get back to work. Hey guys, Kenny just had another question here. He wasn't sure, but he's being a bit camera shy.
All right. So the question is, take the hydraulic rams, a nice jig, lift up the lower car. When I lift it up to where I want it, I can't just let this thing down. So the question begins, where do I weld this thing together in order to make it stay?
You want to lock it. You want to lock it down.
Yeah.
Okay. Depending on the car style, on these 90 footers, you will need to weld something up underneath the rail car, so that now they're locked together. So underneath that C channel, you need to add another plate on the bottom,
Like a piece of angle. Or...
like actually one of these. So it'd be like one of these, right?
Mm-hmm. And
you would weld it. Actually, can somebody give me a hand here? You want to weld it just like this up underneath. All right. Yeah, you just want to get some angle and weld it just like that, right? So you want to shim it. You want to do whatever you need to do in order to get a good weld. Okay, so that's one way to do it. Another way to do it is up inside this little pocket here. You'll want to get some flat bar. You want to weld some flat bar. The flat bar is in this direction, this way. Okay, so a little piece of flat bar is coming out this way, right? Another little piece of flat bar over here, and then you'll want to weld a plate connecting those two flat bars together, right? The alternative would be to get a perfectly shaped piece of steel, that was shaped like this. I went from here down across here, went up. It was just a perfect sized plate. But that's going to take too much work to get a perfectly sized piece of steel to fit there. So instead of using one plate here to fill this gap, because if you were to use one plate here and weld that up, it's going to lock it in place, right?
Yeah.
So instead of using one solid piece, we use a flat bar here, small little flat bar, just 1/4 inch by maybe 2 inch, just a piece of flat bar here and a piece of flat bar here, right? And then you add a filler piece that attaches to both flat bars. Now it's locked in place. Now whenever you let the hydraulic cylinder go, this is locking it in place.
Yeah.
Okay, does that make sense with the flat bar?
The flat bar is pretty simple. With the angle though, how do you get it underneath? Do you just
You have to physically go underneath the bridge.
go up underneath the bridge and do it? Okay, so the flat bar would be maybe a better choice if the application was right.
If you have a tight access,
Yeah.
or if there's a giant river underneath you, then yeah, going underneath with the flat bar can be a little bit more difficult. But one piece of flat bar is easier to weld than,
You mean one piece of angle?
I mean, one piece of angle is easier to weld than flat bar with another flat plate in between.
Yeah.
So that's doing it on top takes 3 pieces of steel. That only takes 1. So is it better to work with 1 piece or 3 pieces? Depends on the application.
Right on.
Right? And so if you do that, that's where Jesus was talking about how you really want to do this like every, it depends on the application, 5, 8, 10, 20 feet. On the 90 footers, we maybe only want to do it, once in the middle and at the quarter points. That's, that's like every 30 feet or so. But once you get to the worst area and you lock that camber down to where you want it to be, when you let the cylinder go, it stays where you want it to be. It's not going to move anymore.
All right.
Does that make sense?
Makes sense.
Any more questions? That was good. That was a really good question. I'm glad you brought that up. Any more questions before I turn off the camera again?
Not on this day.
All right.
All right.
Can we get back to work now?
Yeah.